Welcome back to Orlando Math Learning Academy, and it's been a week. It's been more than a week since the last video. So last week we talked about a piecewise function. Today I want to teach you how to solve absolute equation and absolute inequality. But before we start our lecture, I want to do a quick recall what absolute value is. Then from there we will know what absolute equation is. Okay, so absolute value basically is the distance, of course, from the origin to that value, and because it is distant, so it always positive. That's why when you take absolute value of a positive number or negative number, it always turns out to be positive no matter what. Okay, then from that concept, we know what's meant by absolute equation. Okay, so today we're talking about absolute equation and absolute inequality. So let's put our topic today: absolute equation and inequality. So on the first part, I want to talk about how to solve absolute equation. Okay. So what is meant by absolute equation? What is absolute equation? How is that related to absolute value? Okay. So absolute equation basically it's just a equation. It could be but the equation that has the absolute bar. It means it has an absolute an absolute function in there. Okay. And when you solve for absolute equation, similar to any solving absolute solving equation, when you solve for absolute equation, you solve for the value, which when you plug that value into the absolute equation, it satisfies the whole equation. Okay. All right. And unlikely to regular equation, absolute equation, most of the time they have two answers, because remember when you when you learn absolute value, when you take absolute a positive number, it gives you positive. Even when you take an absolute of a negative number, it also gives you a positive number. So there are two cases. And that's why when you solve absolute equation, most of the time they have two solutions, but sometimes it might have only one. Okay, it might have only one. Okay, and how will I solve absolute equation? The method, the approach to solve absolute equation is to bring a very complicated. Sometimes the absolute equation is very complicated. It's not just simple. Okay, we need to bring the equation into the form absolute of A equal B. Okay, so as long as we can bring absolute complicated absolute equation into this one, we can solve it easily, because this is a basic absolute equation. So this equation, this absolute equation, contains one pair of absolute bar. Okay, sometimes it has two pairs. Sometimes it's like this. So right now we just focusing on how to solve absolute equation that will be in this form or in this form. Other than that, we haven't learned how to solve it yet, of course, there's something more complicated. Some absolute equation contain 3 pairs of absolute bar or 4 or 5 pairs of absolute bar. It could be like that also, not just 1 pair of absolute bar or 2 pair of absolute bar like this. Okay, so this is our goal. We need to bring into this form. Okay, example. Let's take a look at the one of example here. Let's see. For example, I have x, absolute of x plus 6 equal 13. Okay. So this is the absolute equation, of course, right? Because it contains absolute bar, and you can see right away that the equation here is in the form, as I say, is in the form absolute of a equal b. In this case, a is x plus 6, b is 13. And because it's in the it's in the form, so we can solve easily. So how are we going to solve this? Remember, as I told you, absolute value will give you positive and negative. When you take positive, absolute of the positive number give you positive. When you take absolute of negative number also give you negative. Okay, so it means that I can split up into 2 cases. One is positive, or one is negative. Okay. So after you split into 2 cases, that become a very simple linear equation, and now we can solve easily. So this give you 13 minus 6 is 7, and negative 13 minus negative 19. Okay. Now, how do we know that this equation this answer here satisfies the equation? Well, actually, most of the time it satisfies the equation, yes. But by just do the quick check over here, you plug 7 into the equation. 7 plus 6. 7 plus 6 is 13. Absolute of 13 is 13, right? And negative 19 plus 6 is negative 13. Absolute of negative 13 is also 13. Okay. So when you have it in this form, basically what we can do is we can split it up. We can split up into 2 cases, one positive and one negative. Okay. Now let's do another example that is in this form. And let's do example number 2. Something like let me pick something complicated. I mean, how about this? Okay, let's see. Okay, let's do this. Absolute of negative 4x minus 7 equal absolute of 9 plus 7. Okay. So you see that it's in the second form, not in the first form anymore. A in this case is everything inside here, A, and B is everything inside here. Okay. And because we have 2 pairs of absolute bar, it means that when you take positive or negative, it's turn out to be the same value. Okay. It means that we can also split it into 2 cases. The first case is negative 4x minus 7 equal 9 plus 7x, or negative 4x minus 7 equal to negative of 9 plus 7x. And this is very simple linear equation, so I can solve it. Negative 16 equal 11. right? 7x plus 4x is 11x, 16, so x equal negative 16 over 11. And over here I distribute the minus sign in, so I have minus 9 minus 7x, so we give you 3x equal to negative 2, then x equal negative 2/3. So we have two answers, and I don't even need to check. I'm sure that when you plug these two answers in, it satisfies this absolute equation. Okay, so based on these two examples here, I can write a general method when you solve absolute equation for these two cases. Okay, let's write it. Case for these two methods, I mean for these two formula. So first form 1, absolute of a equal b, then I can split up a equal b or a equal negative b. Okay, the second form is absolute of a equal absolute of b, then a equal b or a equal negative b. Okay, however, most of the time they don't give you such a problem as simple as this. You have to bring it back to the basic form. Okay, let's do another example, something more complicated. Okay, example number 3. And you will see it's not just simple as this. We have to do more steps to bring it back to the original form. Then use this formula, the method here, to solve for the value, to solve for the answer. Okay. For example, I want to solve this. Negative 3 2x minus 5 minus 3 equal to negative 12. Okay. Let's analyze this absolute equation. I know that this equation contains one pair of absolute bar, not two pairs. It means that I'm not going to use the second form. I have to use the first form. Okay. However, it's not totally in the form yet, because this form we have absolute of a equal b. We don't have any other number on the left side. We don't have a bar on the right side. We have only number or number with variable, no bar on the right side. Now look at example number 3. On the example number 3, in front of the absolute bar we have negative 3. Okay, we're not allowed to have this. If we want to use the first form, we're not allowed to have negative 3 in front of the bar right here. Okay, and we also have negative 3 here after the bar. So look at the form. We don't have any number after the bar, right? No. However, in the example number 3, we have negative 3. So we're not allowed to have that number over here. On the right side is good. On the right side, we have negative 12. That's perfect. Okay. Okay. So, in order to solve this, we need to bring it back to this form. It means that we have to get rid of negative 3. We then get rid of negative 3 in front of the bar right here. Okay. So how we get rid of negative 3? We just add both sides by 3. So if I add both sides by 3, the left side I have this, and negative 12 plus 3 is negative 9. Right? Then afterward, I get rid of negative 3 by divide both sides by negative 3. So if I divide both sides by negative 3, so I have negative 3 divided by negative 9 divided by negative 3 give you 3. Look at that. the equation now, the pretty complicated equation at the beginning here, now I kind of simplify to this equation. And the good thing about this equation is it is the first form. A is 2x minus 5 and b is 3. And because it is the form absolute A equal B, now I can solve for it. I can split it up into two cases. And I can solve easily. Okay. Okay. I'm sure that it's these two answers here must satisfy the equation, of course. Okay, so the example number 3 over here represents something more complicated than just the very basic equation as we did in example number 1. Okay, because example number 1 is in the form already. Example number 3 is not in the form. We need to bring it back to the form. So this is the form. Okay. So all I want you to know, or all I want you to remember, is you have to bring any absolute equation back to the basic form. If you cannot bring back to the basic form, we cannot solve it. All right. Now let me see if we have any more equation so that you can do something kind of complicated. Let's see. I have the problem over here, but I don't think this is too complicated. But anyway, I'm gonna just go ahead and do it. So example number 4, right? Last time example number 3, so this is example number 4. Yes. Okay. This is the problem number 21 on page 280. Absolute of 1/2 x plus 3 equal 4/3x minus 1. Oh my god, this problem in this equation, this is in the form already. This absolute equation is in the form already. It's in the form absolute of A. This is your A equal absolute of B. So basically, if you want to solve it, you just apply the method, the general method. Okay. I mean A equal B or A equal negative B. Okay. Or 1/x plus 3 equal negative. Okay. So make sure that when you put negative, when you put negative, make sure that it must be the negative of the difference. Okay, and because of negative of the difference, we have to put parentheses. Okay, we cannot put negative 4x minus 1. Okay, because this is not right. It's not correct do it that way, because this is a negative of the difference, so we have to put parentheses, the negative in front of the parentheses. All right. So I don't think I need to solve this. I think you can handle this easily. But let me see if I can make up something with two absolute bar that require you to bring it back to the form, the second form, absolute of A equal to absolute of B. Okay, let me see if we can do that or not. Let's see, I can make it up something. Well, look like for two pair of absolute bar, we cannot have anything more complicated than that. I mean, yeah. If we have something more complicated, we have to create an equation that contains three pair of absolute bar, not just two pair of absolute bar. But doing that, we have to for those kind of equation, we need to do something else. But I don't think that you need to know that. Okay, let me see. Yeah, I think that's all for the concept of absolute equation. I will find something more complicated to do later on in the future, who knows, or something more interesting which help you to learn more how to solve absolute equation. But right now I think that's good enough. Okay, so remember, all you need to know is you need to bring it back to the general form, absolute of A equal B, or absolute of A equal to absolute B. Then you can split up. If it is not in the form, you're not allowed to split up into two cases. Okay. On the second part of the lecture today, I want to talk to you about how to solve absolute inequality. So second Roman, absolute inequality. Well, the name will tell you everything. The absolute inequality, I mean, this is inequality. It contains absolute bar. So the difference between absolute equation and absolute inequality is, in absolute equation you might have one or two, most of the time two, solution. However, in absolute inequality, you have a bunch of solution, a bunch of value, which means we have a bunch of number. When you plug in those numbers, it satisfies the absolute inequality. Okay, and because the solution is just a bunch of number, then we can represent that solution using interval notation, or we can represent that equation graphically, or using algebraic method, algebraic expression. Okay, so absolute inequality is just the inequality that contains absolute. Okay, and when you solve absolute inequality, the method is not much different in general. It's not much different from absolute equation that I'm talking about general approach. Okay, which means you have to bring it back to the general form. And now I'm going to talk about two general form. Okay, the first one is absolute of A less than B. Less than B or less than equal to B, the same thing. You use the same method, the same formula. Then this is equal to negative B less than A less than B. For example, I want to solve something like this. Sorry, I want to solve something like this. Absolute of 4x minus 6 less than equal to 22. So the first example I have here, it is the form already. A is 4x minus 6 and B is 22. So I can apply the formula, the general formula right away. I mean, negative B less than A less than B. So A over here, this is A, this is B. Everything inside the bar is A. Okay, so this is B. So we will have negative B. It means negative 22 less than A is 4x minus 6 less than B 22. So this is compound inequality. You really learn how to solve this. So I'm gonna add in both sides by 6, right? Between 28 and 22 minus 6 is 16. Okay, minus 16, and I divide both sides by 4, so I have -4 less than x less than 7. So the answer here is in the form of algebraic expression. Okay, I can represent this answer using the interval notation between -4, I'm sorry, this is equal, so it means it's included, and 7. This is in interval notation form of the solution. Or I also can represent this on the number line. -4 here included, 7 here included. So this is what we're going to take between -4 and 7. Okay. So then in this example, it's kind of simple. Let's do another example that's more complicated. For example, I have something like this. -2 plus 3x plus 7 less than or equal 4. Okay, so you see that over here it's not in the form yet. It's not absolute of a less than b. We have number 3 in front of it. We're not allowed to have number 3 in front of it. We have a -2 over here. We're not allowed to have it because you see the general form, we don't have anything here. On the right side is good. We have a number, so that's okay. So what we have to do is just get rid of number 3 and -2. And I have to get rid of -2 first, of course, right? I add both sides by 2. 2 less than or equal 6 and divide by 3. Now what? The original equation becomes simpler. Why simpler? Because it's in the form absolute of a less than b. A in this case is x plus 7, b is 2, and because it's in the form already, I can split it up. I can write the answer like this. So -2 less than x plus 7 less than 2, and I can solve for that easily. Right. And of course I can, this is again this equal sign, so include this, so I can write it in interval notation like this, and I can write it using the number line. Right. So you will not see anything more complicated than this in this course. Okay, of course I can make up something very interesting, very fancy, and sometimes you have to take it might take you like half an hour to think about how to solve it, but at this level you don't need. This is all you need. All right. The second form I want to talk about is the first form. The second is absolute of a greater than b. This is less than, this is greater than. So if absolute of a greater than b, then a less than -b union with a greater than b. Example. Again, for this general formula, when you solve this, every time you see the greater than sign, you have to bring it back to this form in order to apply the formula. Okay, this is the formula. This is the formula. Okay, for example like this. 3/2 absolute of 2x plus 3 greater than equal 4. So in this example here, I see right away that it's not in the form yet because I still have 3/2 over here in front of the bar. You see that? We don't have anything, but over here I have 3 halves. It means I have to get rid of 3 halves. And this is multiplication. In order to get rid of 3 halves, this is fraction. I just multiply both sides by 2/3. 2/3 and 3 halves cancel out. Okay. So become this times 2/3. So your equation, your absolute inequality become greater than equal to 8/3. And now it's in the form. A over here is 2x plus 3. B is 8/3. So I can apply the general formula. It means I have 2x plus 3 less than equal to negative 8/3 union with 2x plus 3 greater than equal to 8/3. Alright. So I keep solving. I mean 2x plus 2x less than equal to negative 8/3 minus 3 because I subtract both sides by negative 3 here. Okay. Union with 2x greater than 8/3 minus 3. I subtract both sides by 3 over here. Okay, so it means I have the equation is 2x less equal to negative 17/3 union with 2x greater than negative 1/3 and divide both sides by 2. I have 9 and greater than 1/6 union. So if I use the interval notation over here with the union, I have to use the union sign also. Will be negative infinity to negative 17/9 because it's included everything less than negative 17/9 included 17/9. It means I have to use the bracket. All right, bracket greater than negative 1/6 to positive infinity. Okay, and we can graph the solution on the number line. Negative 17/9, negative 1/6. So it's gonna be here, here, greater than on the right side, and less than on the left side. Okay. Okay, so in general, when you solve absolute equation, you have 2 forms, and when you solve absolute inequality, you also see 2 forms. So totally we have 4 formulas. Okay, 4 formulas to solve absolute equation or absolute inequality. And remember, you must bring it back to this form in order to apply the formula. If you have something fanciful, more complicated, then you have to manipulate some way, somehow, so that it bring it back to the forms. Okay. If you couldn't bring it back to the form, then no way we can solve, no way we can apply this formula. Okay. All right. Next, let's see. We can solve absolute inequality graphically or not. Okay. Let me see. I think we can also. Okay, because you remember that when absolute function is the V shape. Okay. If you have the form absolute of A equal B, then it means that on the left side we have the function, absolute function of the V shape. On the right side we might have the linear function or just a constant function. Okay, then we find the intersection point between the V shape and that linear function on the right side. Okay, on the right side right now you have only the linear function. I don't think you will have quadratic function yet. Okay, so just linear. So when you solve absolute inequality or absolute equation, you can solve it graphically, okay, by just go ahead and graph two equations and find the intersecting point. Okay, let's go through one example. Okay. Number 3, solving using absolute equation or inequality graphically. Okay, let's do two examples. The first example I will do for absolute equation. Okay, let's see if we can solve this. Let me see. Okay, something like this: 3x minus 4 equal x plus 1, for example. Okay. And this is a simple form. This is in the first form already. It's very simple. We don't need to manipulate to bring it back to the original form because it's already in the original form. Okay. And again, I always said on the left side we have the absolute equation. I mean, we have on the left side is absolute function. It means they have V shape. So we need to grab the left side first. Okay. How you grab the absolute function? You remember? You can plug it upon, but I mean plug it upon is very kindergarten method, so I don't want you to learn that way. Recall the absolute function has this form: ax minus h plus k. A is coefficient, so over here the function we're considering is fx equal 3x minus 4. So we need to manipulate a little bit so that it's in this form. So what I'm gonna do is I'm gonna just factor number 3 out. There you go, like this, right? Now a is 3, it means the slope is slope 3 over 1. H and k basically is the vertex of the V shape, you know, at the point. H is the x component and k is the y component. Okay, so H is x component, so the vertex has a form 4 over 3, 0. The slope is 3, 1, so 4 over 3, 0. So 4 over 3, 0. Let me see. 1, 2, 4 over 3 about 1. 4 over 3 is about 1.333. So 1 here, 1.3 over here. So the vertex is right here. And I know the slope is positive. I know that the V shape will open up. And the slope is 3 over 1. So if we apply the rise over run method, so 1, 2, 3, going to the right 1. There you go. So it's going to be like this. Okay. Oh, sorry. There you go. There you go. So that is the equation on the left side. The equation on the right side is x plus 1. This is linear equation. Slope intercept. The slope is 1. The y-intercept is 1. So over here, 1, 1, 1. 1, 1, 1 is the increasing. So it's going to be like this. It's going to be like this. There you go. So you see that the line x plus 1 is intersecting the v-shape at 2 points, this point and this point. So the x component of this point and this point here is the solution of the absolute equation. Okay, so I call it x1 and x2. And I feel like the x2, I mean, because I don't have a graphing paper over here, so I cannot get the solution exactly, but I feel like the second solution seems to be let me see, seem to be it looks like it's 2, but I'm not really sure. And the first solution seems to be 1 point, I think, no, like point something here, point something. So the bad thing about showing graphically is that you must have the graphing paper in order to get the exact solution. Even you have a graphing paper, sometimes it's very hard to get the exact solution. Also, because sometimes the intersection point is like in the middle of nowhere, it's not really on the grid. So that's the bad thing about graphically showing graphically. However, that is the method. The method of showing equation graphically is to find the x components of 2 intersecting points between of 2 functions. Okay, so that is the method to solve absolute equation graphically. On example number 2, I want to solve absolute inequality graphically. Let me pick something. Let me pick something simple, something like this. Okay. Again, on the left side, we have the first function is f1x equal -4/3. And the right function is just a constant function. So I just go ahead and graph it the same way, the same step as you solve absolute equation graphically. However, there's some difference. Okay, but first of all, we need to get the shape first. We need to get the shape. Okay, so for 3 here, so slope is 1 right here. For 3, you mean the vertex is 1 point something. Slope is 1. So 1.3, this is 2 right here, it's 1.5 right here, 1.3 about right here. This is a vertex, and the slope is 1, so move up to the right, so it's kind of like this, again. My graphing paper, I don't have graphing paper, so it's kind of tough to get exactly, you know. And the second equation is 2, so 1 over here, 2 here. Okay, this 2. All right. Okay, so the inequality here, the inequality sign here is less than. Basically, literally, it means that the function on the left is less or below the function on the right. So the solution of absolute inequality is all the x value that make the f1 function or the function on the left below the function on the right. So this is f1, this f2. Okay, now tell me where the part, okay, which part of the graph here, which part on the coordinate axis here f1 below f2. Below f2. Okay, we have to see. It look like it's only over here, right? Because it's f2 over f1 over here, f1 here. Look at that, f1 over here, f1 here, f1 here, f1 here, but f1 over here above this. You see that? This above. So only the part here, f1 below. You see? F2 above, right? F2 right here. Just let me draw it over here. I kind of zoom it up. You see, that's F2. Okay, and F1 is like the side of the triangle here. F1 right here. F1 here. Okay, let me use different color. F1 is in blue, and F2 is in red. Okay. And now you will see that F2 is above, right? It's above. This, just draw a vertical line. If I draw a vertical line, I touch F2 first, then F1, right? I touch the red one, the red line, before I touch the blue line. It means that F2 above F1. So all the value between here and here, okay, all the value between here and here will make F1 below F2. So I don't know exactly the value because again, my graph, I don't have graphing paper, so but I know that as long as you can find the x component of these two intersecting points, then you can write the answer in this form. X1, x will be less than x2 and x1. Okay. X1 and x2 is a number, you know. I don't know exactly what number because again, that's the negative side of showing graphically, because you don't know exactly the value. Even you have graphing paper, you sometimes you cannot get the exact value. That's why on the test or on the exam, usually I give you the graph already, or usually make you to solve the inequality or the equation algebraically, not graphically. Okay. Okay. Okay, so for the fourth part of the lecture, we talk about the modeling with absolute equation and absolute inequality, but I don't think that I'm gonna go through that right now because I think this is hard for you already. So I think I'm gonna just go ahead and skip modeling with absolute inequality and absolute equation. However, if some of you already master how to solve inequality and equation, you can ask me how to do modeling with this absolute equality and equation. Okay, but right now I don't think I have to. I should go through that because I don't want to mess you up. So as long as you grasp this concept, you know how to solve absolute equation and absolute inequality manually. I mean not graphically. Then it should be okay to me. Okay. So I think that's all for the lecture today. Please again, if you have any question, just let me know, and you can ask the question under the YouTube video. And on the next video, I will jump to. So this is the end of chapter 3. In the next video, we will be starting chapter 4. It's about a quadratic function. Okay. Alright, so that's all for today. I'll see you next time. Alright.